now we're going to look at how we determine the range of a function. Not every function, but some certain functions that we can show you how to determine the range of a function. So let's take a look at a couple. Okay. Let's recall this graph, y equals 1 over x. Okay. Our graph, we know, was the one with the hyperbolas. Okay, I'm getting ahead of myself here. So we've got the domain was that we could not have 0 as a value. Okay, so we said that since the domain was everything but 0, then the domain is from negative infinity to 0 in union with 0 to infinity. Okay, now I want to know what is the range of the function. What is the range of the function? Since we were able to easily able to determine what the range was because we could not let our denominator go to 0. Okay, because we had x in a denominator, we could not let that equal 0. So that was facilitated easily because the function notation is synonymous with the y as a function of x. So we could return to out of this function mode, if you will, for now, to the expression y equals 1 over x. Now what we want to do is we want to put y in a position so we can determine what it cannot be. Okay, so that's a simple process, simply cross multiplying. All right, if we cross multiply, of course, we get xy equals 1, and then that could easily be solved for x in terms of y, in which case we get x is equal to 1 over y. Now we should be able to say, well, y can't equal 0 now. Y can't equal 0 because 0 in the denominator would make this expression undefined. So we have effectively determined the range of that function. Since y cannot equal 0, then we have to say that the range is everything but 0 as stated here, and the graph kind of supports that. Okay? Okay, determine the domain and the range of this function. All right? You'll say, well, the domain is easy to find. Yes, it is, because we cannot let x equal negative 4. It cannot let x equal negative 4. So since it cannot equal negative 4, it is everything but negative 4. So the domain is stated here. Negative infinity to negative 4 in union with negative 4 to infinity. Now, we're wanting to know what y can or cannot be. That is, we're after the range of this function, or after the range of this function. Well, the range of this function will be facilitated if I can get y and if I can get my y in the denominator. So then I can see what y can or cannot be. So that's exactly what we're going to do. Again, the function might have been expressed as f of x instead of y, but if it were, we easily know that f of x and y are interchangeable. So here we go. We start with this, we cross multiply. We come down to this stage, okay? Come down to this stage. Y times the quantity x plus 4 is 3 minus 2x. Distribute the y. So we get yx plus 4y equals 3 minus 2x. Now what are we after? We're trying to isolate x now. We're trying to isolate x. We're trying to write x as a function of y. Isolate x. So let's begin by putting our x terms together on one side, as we did here. And now we can factor out that common factor of x, okay? And we get this. Now simply dividing by y plus 2, we will have x by itself, okay? And having x by itself, we can clearly see that y is not going to be equal to negative 2. That y is not going to be equal to negative 2. All right? And so since that is what y cannot equal, we now know that the range is everything but that, which is negative infinity to negative 2, along with from negative 2 on out. So given the domain, and there's our picture. There's our picture of that function, all right, which clearly says that, as we saw, x cannot equal negative 4. So here's negative 4, and there's an asymptote occurring there. Now, that's our what we'll call our horizontal asymptote, okay? We will also have a vertical asymptote the which we found is where the range is undefined, which is at -2, and you can see that this thing is skirting along an imaginary line here at y equals -2. That would be called our vertical asymptote, So we have the horizontal asymptote at x equals -4, the HA, the ha, and we have the vertical asymptote at y equals -2, okay, which is the VA or the va. And most of the time we're after the ha and the va, okay? Now, let me show you that on the calculator. So on the calculator, I'm keying in that same graph. So there is that same function, right? 3 minus, it's the same function. Now that's not the one that's shown in the background, but it's the one that just showed. 3 minus 2x over x plus 4. So we found that the vertical asymptote was at -4. Okay, that is the restrictions in the domain. Okay, x can't equal -4, and we found that y couldn't equal -2. So the graph kind of supports that. And you say, how do you know that thing's never going to equal -2 for the y value? Well, here's what we're going to do. We're going to show you working with the table. We're going to show you working with the table. So when I want to go to the table, these are F4 and F5 commands up here, but they're diamond green commands. So they're diamond F4 and diamond F5. So I'm going to go to diamond F4, where I set my table. Now, the table start is totally arbitrary where you want it to begin. Where you want the increments to begin is totally up to you too. So let's just say we start at -1, okay, and we just go in increments of 1, okay, and then we just keep that as it is, and then we accept that, okay, and now we go and look at the table, and the table then shows, okay, the values, okay. So what's happening? We said that that the graph, go back to the graph a minute, okay, that the graph will never get to a y value of -2. So what we're going to imagine is we're going to put in larger and larger values of x, okay, because it seems like if you keep the values of x increased, this thing is going to start getting towards -2. Well, let's show you from the table perspective, second F5, how that is the case. So here we are. Let's scroll down. Let the x values increase. Okay, you see that this thing go out further and further. We're down to negative. Let's go out to 20. We're seeing at -1.5. Does it get close to 2? Well, here you might be at this all day. Here's a better way. Go back to the F4, diamond F4, okay, go back to the diamond F4, and let's take this option, okay. We're going to come down to this where it says auto, and we're going to take the ask option, the ASK, okay. Now, just select that and enter, and now what's going to happen is you're going to be able to key in the values of x you want. So we have 20, let's go up, let's take that up, well, now we can key in 40, okay? And we can see, well, is that closing in on -2? Well, double that, go to 80, okay? And is it getting closer to -2? Well, no, go up to 160, double it again, okay? Yeah, it's closing in. Yeah, go up to 500, okay? Go up to 500. Is it ever going to get to -2? No, go up to 1,000. So the closer, so from the graphical perspective, okay, from the graphical perspective, that's what we call the asymptote behavior, okay, and that's why the domain will never hit negative. I mean, the range will never hit -2, okay, and that is in agreement with the graph here, okay, and if you wanted to keep scrolling out, okay, you'd see that this thing is just going to start skirting that horizontal line of y equals -2, all right? And that's what's going to happen, okay? So there you have some graphical interpretation of the domain and the range. Okay?